everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics. Today we will continue with model specification, and in the last lecture we have discussed this issue. In fact, when we talk about model specification, it may be either the involvement of number of variables. This issue is either less number of variables involved in the process as per the requirement, which is called as under identification case, and in the second instance more number of variables involved as per the particular requirement, and that is the over identification case. And we have discussed both these issues, and we have gone through the discussion and come to a conclusion that we need actually optimum number of variables, and that to be in the system through which model will be free from all kind of bias, and then can be used for the decision making process. In the second instance, a particular models may be free from all the tests, starting with the specification, goodness fit test and all kinds of diagnostics. Still the model may not be actually good to use for the decision making if again it is misspecified, that too not with the issue of variables involvement, over identification case or under identification case. Here it is the issue of functional form. Sometimes when you estimate a particular equation, so be careful what is the functional form we have actually specified there. So, if the specification is not good, then by default the estimated output may have some kind of bias again. So, as a result this model cannot be used for decision making process. Again, whatever may be the engineering problem. So, so ultimately we have to again check whether the model is correctly specified or not. So, there are again lots of standard checks are there. We start means the usual procedure is as per the classical linear regression modeling, that you start with the linear structure, and by using the linear structure, if the estimated model or estimated outcomes are passing through all the kind of diagnostics, then by default the model will be declared as correct specification. But if there is some blocks and there is a high chance it may be due to misspecifications, and that too because of uneven functional form. So, that means the requirement is let us say exponential type, but the ultimate use is the linear type. So, now if you change the functional form and re-estimate, then by default the model will be free from all errors or all diagnostics, and then that can be used for the decision making process. So, what is the requirement? So, the same problem you have to change different kind of functional form, then look for the estimations differently, and by default you will have a different alternatives. Even if the model actually correctly specified, no harm to re-estimate the particular model. Means in this case what is happening here, the variable pools are constant, which we have actually taken care by the previous discussions. Ultimately we have to declare that it is not the under identification case, not the over identification case. So, it is the exactly identified. So, if that is the case, next check of this misspecification is the functional form. So, now the previous discussion will give you the kind of idea that this is what the exact number of variables should be in the system, and now the question is how these variables again will be in a particular setup. Is it in a linear setup or is it in a nonlinear setup, and if it is a nonlinear setup, is it in a exponential type, is it a logarithmic type, or is it in a kind of quadratic forms or polynomial form, or whatever may be the kind of ways we can actually represent. So, ultimately what is the process? So, what will you do? So, number of functional forms you have to create, and then again re-estimate and check the output with the previous output which you have already as per the misspecification test, and then you declare that again the model is correctly specified with respect to its functional form. It is not that model is correctly specified with respect to variables involvement. It is also required that the model should be declared that correct specifications with with respect to particular functional form. Let us see what are the ways we can actually check and ultimately go about it. So, ultimately when you start with estimations, so we have actually a important things what we call as beta 0 and beta 1, two important what we call as coefficients. So, ultimately the coefficients significance will give you the indication that whether the variables is very important or whether the particular model is free from all kind of bias before you use for the requirement. So, what we can do here? So, first we will check with the model like say starting with let us say we start with y and x ultimately like this. So, let us say y and x. So, usually what we start as per classical linear regression model. So, we start with the connecting beta 0 plus beta 1 x 1 plus error terms. Now, the issue is whether there is a requirement of beta 0 or whether there is no requirement of beta 0, that itself is a kind of functional form. So, that means, if it is actually no requirement of beta 0, then the function with linearity it can start with like this, and if you involve beta 0, then the model can start with the predicting like this. So, ultimately, so this is what the kind of difference. So, whether the model will start with origin or start with some above than origin, that is what the intercept is all about. So, this itself is a kind of the kind of misspecifications. So, if the requirement is with intercept, you are bound to have intercept. If the requirement is within origin, then you can start within origin. For instance, in engineering economics, we have actually theoretically we have a cost functions. If you are means cost function, if you say cost function, it is the relationship between cost and output. So, now cost can be variable cost, can be total cost. When it is total cost, so it involves variable cost and fixed cost, but when it is variable cost, so fixed cost is not there. So, now when you are in a spreadsheet showing output with variable cost, so then you can simply start regressing from the origin, because it is the meaningful kind of structuring. But when your Excel spreadsheet will give you the data of total cost and output against all output, then you should actually involve intercept. So, because the intercept will take care of the fixed cost part. So, that is the theory will give you the indication whether to start with origin or whether you start with actually above than origin. Ultimately, even if you have theoretically you have no clear idea. So, what is the requirement, ultimate requirement? That is what the misspecification is all about. You have to check and declare that this model is correctly specified, not only with respect to functional form, but also with respect to the involvement of intercept and with intercept, without intercept. So, ultimately you can estimate the model with intercept, we can estimate the model without intercept. Sometimes we can also estimate the model with trend vectors. So, without constant, without kind of trend we can estimate, with constant you can estimate, and again with constant and trend you can estimate. So, there are three levels you can actually estimate the process, and all these actually checks you are supposed to do before you declare or before use this model for the a kind of engineering requirement. So, that means you are supposed to know what are the ways you can check and then finally you can declare. That means the requirement is here in specification. If the requirement is the involvement of intercept, you should involve beta 0. If there is no requirement, you can skip beta 0. So, ultimately you cannot take a decision until unless you check and verify the results. So, you first estimate the model with beta 0 and without beta 0. That is what called as for instance, if we use a software like SPSS, SPSS will give you two sets of output with coefficient and without coefficient. That is what called as standardized, unstandardized and standardized. The moment you will go for standardized, then by default intercept will be removed in the process. So, it will take you to the origin to have the output, and again unstandardized means it will take you the kind of estimations with intercept. So, this is one way so far as a functionality is concerned, because ultimately it is the function between y and x. So, when I am writing y as a function of x, it may be starts with origin, so simply y equal to beta x, or simply we can say y equal to alpha plus beta x. So, both the functions are true, but ultimately which one we have to use for the decision making process. So, until unless you check and verify, you cannot use this particular model for the requirement. So, this itself is a kind of misspecification check you are supposed to do and go ahead with the requirement. So, let us see what are the other way we can actually observe this point, and let us say various alternatives means one is with intercept, without intercept. Again there are various functionals you may have. So, the first one is the linear one. So, that means if you say functionality technically, if you say functionality this ones, so it may be actually two types, linear one, linear ones and non-linear ones. If it is between actually y and x, so the linear representation will be like this: y equal to beta x plus u, or beta 1 x let us say, and y equal to beta 0 plus beta 1 x plus u. So, this is linear without intercept, this is with intercept, and again when there is a non-linear, so this will take you to this basket. Then when it is a non-linear, so then this may be many different forms, again with intercept, without intercept. So, that means different levels of structuring. So, every levels specify the functionality and then go for estimations. So, the involvement of data is remains same. Now, we are changing the functional form and estimating the model. That means, here variables variable is constant, number of variables involvement is constant, size of the data is constant. What we are checking the kind of specification is with respect to functional form. One way we can call as robustness checks, having different functional form with the specification of number of variables and the kind of size of the data, then you are checking that whether the model is correctly specified, or that means technically whether the model is good enough, estimated model is good enough to go ahead with the predictions or the kind of decision making process. So, here is the game. So, we like to check what are the number of ways you can check or you can estimate the models and declare that this particular functional form is good to go ahead with the forecasting. So, this is second levels, where the model is actually y equal to beta 0 plus x to the power beta 1. What is happening here? So, the variable means it is not linear in the coefficients. The coefficients are means we will have two different ways. The variables are linear in nature and coefficients are linear in nature, and variables are not linear in nature, constants are not linear in nature. For instance, in this functions, variables are actually linear in format, but it is a nonlinearity in coefficients. So, means all kinds of specification will be there, but ultimately we will check actually, and so far as a classical linear regression modeling is concerned. So, the parameters are linear in nature. We like to check the variables structural form ultimately. So, let us see how is this particular flow. So, a linear form in the case ultimately what will we do in the modeling after the estimations, we like to study the impact of that particular variable with the dependent variable, and that is how we like to check the elasticity. Okay. We like to check the elasticity coefficient. So, here is the elasticity coefficient. For instance, if it is y equal to beta 0 plus beta 1 x 1 plus u. So, dy by dx 1s will give you the beta 1 coefficient value. So, that is the weight you can actually estimate. So, that means once you estimate the models, so you can get the beta coefficient, that is the elasticity, which can represent that a 1 unit change of independent variable, what is the impact on dependent variables, and the unit change of independent variable to the dependent variables varies. That means that particular weight will vary depending upon the various functional form. If the function is linear ones, then the particular elasticity may be different, and when you will change the functional form, then the weight will be slightly changed. So, that is why picking up a perfect functional form will have a right choice for the decision making process, otherwise it may give some kind of bias results. So, you must be very careful about this particular structuring, and that too first one is the linear form, and if it is not linear form, then we have a different kind of labels. So, one of the particular label is actually log form, and when we call as log form, and that means actually when we say that dy by dx. Okay, so, that is the coefficient through which you actually you are getting the particular weight factor, but now when the functional form will change, then ultimately it will have a different value altogether. For instance, let us say exponential type logarithm means its a counterpart is the exponential. So, let us say e to the power b equal to x. So, that means, so here actually the value e value will be added here into the process to represent the impact of x. So, log x equal to b. So, ultimately x equal to e to the power b. So, that means see here, if you compare these ones, log x equal to b. So, that means ultimately when I am writing y equal to beta 0 plus beta 1 x plus u, and ultimately x is nothing but actually log x. That means we have transferred the data. Then in that case, your x value will be e to the power b only. Now, if it is only x, then it is simply b. So, now e to the power b and b, there is a big difference, and that is what the functional form will give you kind of difference, and that any minor difference may affect the decision making process. So, that is why this particular misspecification need to be checked, and then you should declare that the model is correctly specified before you use this model for any kind of decision making process as per the engineering requirement. So, ultimately actually this is altogether understanding of the log, and log 100, log 1000, log 1 lakhs, like that how what is the weight we can actually put. We have already put log e here, and then log 10s, log 100. So, that is the value actually. That means the weight of this particular variables will added in a multiple ways. So, that is why transferring the kind of variables and the kind of functional form will have a different kind of weight structure and the different kind of outcome altogether. So that means technically the summation is that it is the it is a kind of mandatory requirement to check this particular misspecification that true with respect to various functional form. So, here if it is a log, then there are three forms, either kind of double log, or it can be a semi log, or it can be either way with original variables with log variables. So, that is what kind of semi log and the kind of reverse way also. So, if it is a double log, then that means both the sides you have to take the a kind of logarithmic, for instance dependent variable and independent variables. So, this is the right case. Here the ultimately we have variable y x1 and x2. We can simply start with y equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus u. Okay. But ultimately you can go ahead with the estimations and have the output, that is what called as output with respect to linear functional form. Now, what will we do? We change the orientations. Now, instead of y x1 and x2, we transfer the data log y, log x1 and log x2. So, now the same models we can estimate, but here the data will be not the original data or the actual data, it is the transposed data, and the transformation is the logarithmic transformations. So, ultimately, we have to, instead of y we use log y, instead of x1 we will use log x1, instead of x2 we will use log x2, and the difference will take care actually at the elasticity level only. So, here it is not dy by dx1, it is the d log y by d log x1. So, this will give you different kind of look altogether. So, delta of log y means if you simplify, it is actually the kind of elasticity coefficient. So, y by x dy by dx. So, that means y by x, that is the coefficient is having more another weight will be added into this particular process if you change that particular functional form. So, means a simple to some double log functional form. So, that is the difference you will find here, and that is how there is a high requirement of checking the misspecification of the models by changing the functional form. And you see here, and this is how the ultimate graphical look about these estimations, and it is a logarithmic function. And so plotting can tell you somehow like we need theory to integrate. So, what kind of functional form we can use, whether it is the log x or simple x or log y or with a simple y. So, after plotting you can get to know little bit structure. Even if you cannot able to plot, so no harm actually, you just arbitrarily change the format and then re-estimate and again compare these outputs and finally declare that this is the functional form through which model should estimate, and then the estimated outcome can be used for the kind of engineering requirement. So, that is the choice, and you will have different kind of setup. So, if not double log, and then we have a semi log. So, here y is the original actual and x1 is actually transport, that is instead of original x1s we will use log x1s and then again x2. So, that is also allowed. So, that means log y and x1 and x2 against y with log x1 and log x2 against y with log x1 and x2, and another way y x1 with x1 with log x2. So, that means these are all various options, single log, double log, against you can actually allow another log both the sides, and then you can go ahead with the estimation. Ultimately, doing all these things you are normalizing the data, and ultimately there is a high chance the accuracy of this particular estimation will be very high. not always true, but sometimes it is also it is, you know, it is the fact. So, no harm again to do this processing, re-estimate, and then recheck the kind of an outcome, and then compare and declare which one is the final choice as per the particular requirement. So, this is the graphical look of, you know, semi-log functions. And okay, so if not actually single log or double log or semi-log or not linear, then there can be another form also, that is called as, you know, polynomial. Polynomial has actually multiple kind of, you know, structure with, you know, single degree means, polynomial of order 1, order 2, order 3, like, you know, that means the moment you will start, you know, using polynomial form. So, you can have actually multiple option altogether, and again it will give you lots of, you know, alternatives, that with respect to functional forms. So, you just specify the functional form and then you go ahead with the estimation. So, polynomial of degree 1, polynomial of degree 2, polynomial of degree 3. Polynomial degree 1 is nothing but called as, you know, linear format. If not, then it will start with, you know, quadratic, cubic, and so on, and every time you like to check whether the particular functional form is very effective so far as, you know, theory and data and the kind of, you know, engineering requirement is concerned. So, for instance, if you say polynomial, at least one of these particular variables should have, you know, polynomial structures, that is the degree should be starting with, you know, second degree. So, it is in a quadratic format, and where we are integrating y with x 1 and then x 1 square and with, you know, x 2. Sometimes you know, doing this, the estimated process will be very effective and it will add value to the systems, and as a result the decision making process will be very efficient altogether. So, again there is no harm to you know, use this form and re-estimate and check and verify the output. Ultimately it is the search process, and in the search process there is opportunity cost. So, every time you have to check which one is good, you have to jump and you have to kick the you know, the other one. So, like that this is the procedure you have to follow, and then go ahead with the kind of, you know, prediction and decision making process. So, this is the polynomial form of the you know, graphics, and that to polynomial of degree 2, and when we increase the degree. So, ultimately graphical you cannot check, but you can mathematically you can connect and estimate. There is no harm at all, and you can also have inverse functions. So, now that means technically same y x 1 and x 2, instead of using log x 1, so we can use actually 1 by x 1s. Okay. So, again we are actually standardizing the particular, you know, variables. So, doing this sometimes, you know, the volatility will reduce, and in that case the model accuracy may be high, but while doing this, so we ensure that, you know, data will be very supportive. For instance, one of the conditions by using inverse function is that, you know, x 1 cannot equal 0. So, in the data set, if x 1 is coming in any sample is coming 0, so by default you cannot use this particular, you know, functional form. So, that is the, you know, restrictions, or we can say that, you know, conditions to use, you know, inverse form. So, when you use inverse form, first check is that, you know, check whether any data for a particular variable is having 0 or non-zero. If it is having at least 1 0, then you should not use these ones, because 1 by 0 by ultimately it will give infinite, and when you use this, you know, value and in software, then the model will not run and ultimately will not get any kind of, you know, outcome. So, that is why before you start the process, you must sure that, you know, it is satisfying the criteria of inverse functions, and then build the functional form and re-estimate the model, and again check the reliability, compare with the other one, and then see whether there is improvement or not. If there is improvement, go ahead and then you block the errors. That itself give you the kind of what we can call as specifications. Other the moment you will say that for instance, you estimate the model in a linear form and then you re-estimate the model in inverse form, and you will find there is a better result here, then by default the previous one will declare as misspecified model. So, you use the inverse form of estimated output, and that output by default will be declared as correct specification. That is what the flow you have to maintain every time. So, this is the graphical look of inverse functions. Ultimately, we have no business about the graphical look, or it's how the requirement, ultimate requirement is the estimated model output, and we like to check whether the model output is very good by changing the various functional forms. So, you start with linear, check the diagnostics, and again check the misspecifications by fixing the optimum variable structures, and then again look for the various functional forms, and then finally you declare that the model is actually correctly specified and free from all the errors, and have gone through all the diagnostics, and then the model is ready to apply for the decision making process and to solve some of the engineering problems. So, that means it is not so easy actually, it is a very complicated game, and it is a very time consuming process, but it is the need and it is the requirement. Until unless you do all these processing, you cannot get a good models, and you cannot declare that this is the model through which you can do the decision making as per the particular engineering requirement. By the way, these are all mandatory requirements, and you are bound to check, and then you will declare that model is correctly specified and the best, and then can be used for the a kind of particular engineering problems requirement. With this we will stop here, and this is all about the diagnostics of engineering econometrics, and in the next lectures we will be starting with nonlinear econometric modeling. So, where we have a various forms of the models, and some of the engineering problems require such kind of modeling to forecast or predict the engineering output or engineering requirements. With this we will close this lecture. Thank you very much.